Picture this. In just a few short weeks, 4 human beings are going to strap themselves to the most powerful rocket ever built and blast off toward the moon. For the first time in over 50 years, humans will venture beyond Earth orbit, traveling further from our planet than anyone has gone since the Apollo era. This isn't science fiction anymore, folks. This is Artemis 2 and it's happening in 2026. But here's what makes this mission absolutely fascinating. These 4 astronauts won't actually land on the moon. Instead, they're embarking on what's essentially the ultimate test drive, pushing humanity's newest spacecraft to its limits while racing around the far side of our celestial neighbor at speeds that would make your head spin. And everything they discover during this 10-day journey will determine whether we can safely return to the lunar surface and eventually push on to Mars. So buckle up, because today we're diving deep into everything you need to know about Artemis 2. We'll explore the incredible machine that's going to get them there, the nail-biting mission timeline that could make or break humanity's space future, and the 4 extraordinary individuals who volunteered to be our pioneers in this new age of space exploration. Let's start with the beast of a rocket that's going to make this all possible. The Space Launch System, or SLS, is basically NASA's answer to the question, how do we build something powerful enough to fling humans toward the moon? This towering monster stands as the most potent crewed rocket system ever constructed. And when it ignites, it's going to produce more thrust than anything we've ever seen with people on board. The SLS design takes some inspiration from the Space Shuttle program, featuring 2 massive solid rocket boosters strapped to either side of a bright orange core stage. But here's a cool detail that perfectly captures the timing of this mission. Those boosters are decorated with enormous America 250 logos, celebrating our nation's 250th birthday in 2026. It's particularly meaningful when you consider that engineers from all 50 states contributed to building this remarkable machine. Above the core stage sits what's called the interim cryogenic propulsion stage, which serves as the rocket's upper stage. But the real star of this show is Orion, the spacecraft that will actually carry our astronauts to the moon and back. Orion itself is a marvel of engineering, consisting of several critical components. At the bottom, you'll find the European Service Module, built by our international partners and responsible for providing power and propulsion throughout the journey. This is essentially Orion's engine room, giving the spacecraft the ability to maneuver in the harsh environment of deep space. Above that sits the crew module, nicknamed the capsule, where our 4 astronauts will live and work for the entire 10-day mission. The Artemis 2 crew has christened their capsule Integrity, and it's the only piece of this massive rocket system that will return to Earth at the mission's end. Everything else gets jettisoned along the way or burns up during re-entry. Finally, perched on top like a protective crown, there's the launch abort system. Think of this as the ultimate escape pod. If something goes catastrophically wrong during launch, this tower can instantly yank the crew capsule away from the exploding rocket below, potentially saving 4 lives in a matter of seconds. Let's hope they never need it, but it's reassuring to know it's there. Now that we understand the hardware, let's talk about what makes this mission so unique and important. Artemis 2 represents the crucial middle step in NASA's plan to return humans to the moon. Artemis 1, which launched back in 2022, was an uncrewed test that proved the basic systems could work. It was a resounding success. But flying without people is very different from supporting human life for 10 days in the deadly environment of space. Artemis 2 will test all the human-centric features that couldn't be evaluated before. The crew will experiment with docking procedures, test radiation shielding effectiveness, verify communication systems, and figure out the mundane but critical aspects of space living, like eating, sleeping, exercising, and yes, using the bathroom in zero gravity. The mission begins at Kennedy Space Center in Florida, launching from the historic Pad 39B. This same launch pad sent Apollo missions to the moon in the 1960s and numerous space shuttle flights into orbit. When the countdown reaches 0 on February 5th, 2026, or shortly thereafter, the SLS will unleash the most powerful crewed rocket launch in human history. The ascent timeline reads like a perfectly choreographed dance of controlled explosions. 2 minutes after liftoff, those massive solid rocket boosters will complete their job and separate, falling back toward Earth while the core stage continues pushing toward orbit. The launch abort system gets jettisoned around this time too, no longer needed once they're safely away from the launch pad. 8 minutes into flight, the core stage runs out of fuel and separates, leaving the upper stage to provide the final push into orbit. After 2 precise burns, Orion finds itself in a highly elliptical orbit, swinging out to 46,000 miles from Earth at its furthest point and coming as close as 115 miles at its nearest approach. During this first day in space, Orion separates from the upper stage and begins practicing docking maneuvers. This might sound routine, but it's absolutely critical for future missions. Remember the Starliner spacecraft issues that kept astronauts stuck on the International Space Station for months longer than planned? That happened because of thruster problems. NASA needs absolute confidence that Orion's autopilot and thruster systems work flawlessly before trusting them with lunar missions. Once Orion completes its initial orbit around Earth, the real journey begins. The spacecraft fires its engine for what's called the trans-lunar injection burn, sending our 4 astronauts on a trajectory toward the Moon. But here's the clever part. They're following what's known as a free return trajectory. This means that if anything goes wrong with the spacecraft, the combined gravity of Earth and the Moon will naturally bring Artemis 2 back home without requiring any additional engine burns. It's the same type of trajectory that saved the Apollo 13 astronauts when their mission turned into a survival story. For a test flight like Artemis 2, this built-in safety margin is invaluable. The journey to the Moon takes 4 days, during which the crew will be busy running emergency procedures and testing systems. One of their most important tasks involves preparing for major radiation events. Deep space exposes astronauts to dangerous levels of cosmic radiation, something that's manageable for short trips, but becomes increasingly problematic for longer missions to the Moon, or eventually Mars. Orion includes a radiation shelter, and the crew will test its effectiveness under real conditions. This data will be crucial for planning future missions that might last weeks or months instead of days. But here's what might surprise you. Artemis. 2 astronauts won't actually land on the Moon. This is purely a flyby mission, similar to Apollo 8 back in 1968. That Christmas-time Apollo flight captured the world's imagination with its famous Earthrise photograph, and Artemis 2 aims to recapture some of that wonder. The spacecraft will travel 230,000 miles from Earth, taking the crew around the Moon's far side, the hemisphere we never see from Earth's surface. At their closest approach, they'll skim just 4,600 miles above the lunar surface, close enough to see incredible detail, but far enough away to maintain that safe, free return trajectory. After the flyby, Orion makes any necessary course corrections to ensure a precise return to Earth. 4 days later, the crew module separates from the service module and plunges through our atmosphere for a splashdown in the Pacific Ocean, where the Navy will be waiting to retrieve our returning heroes. Now let's meet the 4 extraordinary individuals who will make this historic journey. These aren't just astronauts. They're some of the most accomplished people on the planet, each bringing unique skills and experience to this crucial mission. Reed Wiseman will command Artemis 2. This Baltimore native brings 27 years of Navy experience, serving as both a pilot and engineer. He's been an astronaut since 2009 and has already logged 167 days in space. Wiseman combines technical expertise with leadership skills forged in some of the most demanding environments imaginable. Victor Glover serves as the mission's pilot. This California native is a test pilot who's flown 40 different aircraft types across 24 combat missions during Operation Iraqi Freedom. He also served as a legislative fellow with the US Senate, demonstrating the kind of diverse background that makes modern astronauts so remarkable. Glover has been part of the astronaut corps since 2013, Christina Koch joins the mission as a specialist, bringing an incredible array of skills to the crew. She's an electrical engineer who's worked on major scientific programs for both NASA and NOAA. But her background gets even more interesting. She's an Antarctic explorer, a firefighter, and grew up on a family farm in Michigan. Koch holds the record for the longest single spaceflight by a woman, spending almost a full year aboard the International Space Station. Finally, there's Jeremy Hansen, representing our Canadian partners in this international endeavour. Hansen is a pilot, physicist, and colonel in the Canadian military who earned his wings at just 16 years old. He became a firefighter pilot for the Royal Canadian Air Force before joining the astronaut program in 2009. In 2017, he became the first Canadian astronaut to lead a NASA astronaut class. Here's the amazing part. Artemis 2 will be Hansen's first spaceflight. You really can't ask for a better inaugural space mission than a trip around the moon. These 4 individuals represent the best of human achievement and international cooperation. Their diverse backgrounds in military service, engineering, scientific research, and exploration make them perfectly suited for the challenges ahead. The timeline for this historic mission is rapidly approaching. The first launch window opens on February 5, 2026, though like most complex space missions, there may be delays as NASA ensures everything is perfect. Remember, Artemis 1 required a couple of launch attempts before everything aligned correctly, and that patience resulted in a flawless flight. With human lives at stake, NASA will be even more cautious this time around. Don't be surprised if we see a few scrubbed launch attempts as weather, technical issues, or other factors intervene. But when Artemis 2 finally lifts off, it will mark the beginning of a new chapter in human space exploration. This mission represents far more than just a test flight. It's our stepping stone back to the moon, our proof of concept for Mars missions, and our declaration that humanity is ready to become a truly spacefaring species. The 4 astronauts aboard Integrity won't just be testing spacecraft systems. They'll be paving the way for permanent lunar bases, Mars colonies, and adventures we can barely imagine today. The data they collect, the procedures they validate, and the problems they solve during their 10-day journey will directly impact every human space mission that follows. When future astronauts land on the moon, establish research stations, or blast off toward Mars, they'll be building on the foundation that Wiseman, Glover, Koch, and Hansen established during Artemis 2. As we stand on the brink of this new space age, it's worth remembering that we're witnessing history in the making. 54 years after the last humans left the moon, we're finally going back. And this time, we're going back to stay.